Okay, we can get started in another 1 minute. Okay, welcome. This is the DMM working group at IETF 104. I'm Shri Gundavelli. My co-chair, Depeng, is not here. He's unable to attend this time, but we can get started. So quick update, we'll get started with the working group. I think just some basics. This meeting is being held under some IETF rules and guidelines. You should be aware of the participant rules. This is with respect to IPR policy, with respect to participation, other rules, code of engagement rules. Please see the BCP documents. And blue sheets. Just help me out, please. Oh. Yeah, I forgot to mention Suresh our area director Suresh is unable to attend this time. So we have a representative here. Welcome. Blue sheets, minute takers. We need 1 minute taker. I think generally we have a list of presenters and some of them sent their slides late. I think at this time. Carlos, is that you? You did the slides in time? How about in IETF 103? Never? Okay. We need somebody to take some meeting minutes, please. Any volunteer? Okay, thank you. Mia, thank you so much. And JavaScribe, if somebody can monitor the Java. I think there's 2 people. Suresh is online. Danny is there, I think. We'll monitor the Java. So a quick status on where we are with respect to the working group documents. The on-demand mobility document has completed the working group last call. We have forwarded to IESG. It's currently under IESG reviews, and I think there are a couple of discussed positions last I checked, and I think Danny and the authors are addressing those comments. I think that document is in a good shape, I believe. And we have the DMM distributed mobility anchoring document. I think this was in the working group for a long time, but I think thanks to Carlos, he managed to do a good rewrite, and it passed the working group last call. We forward the document to. We are about to forward the document to IESG. I think chair reviews are pending, and my co-chair Depeng took the action item to do the chair review, and after that, once that sanity check is done, we'll forward the document to Suresh for the processing. And we have the PMP6 document. I think this also completed working group last call, but this again chair review is pending. And what I think recently there has been an IPR declaration. I think this was I believe it was posted last week. We are trying to understand the implications of that, because this IPR has been around for a long time, but why we are trying to understand why this was declared so late after the document has passed the working group last call. So I think I don't have any status on that, but I'll check with respect to IETF, what the rules are, I'll check with our AD and others, and we'll take it from there. Yes, please.
Okay, this is Akbar from Interdigital. So just because we made the IPR declaration, but actually, Sri, if you look, our original IPR declaration was in 2012 on the individual draft. But so this was an update. So we actually have made a very early IPR declaration. And the reason for the update was that the patent got issued. So the update was to give the actual patent numbers. So I'm not sure where the confusion is, because if you look even in the tracker, it's there 2012 0319. We made the declaration on the individual draft. So I don't think there's anything late, unless I'm missing something that you're trying to get at.
Okay, yeah, thanks for that clarification. I was not aware of that detail, that there has been a posting on the individual ID. That part, this is news to me. But in general, I think anytime there's IPR declaration, we activate some process. Sure. We'll do that as well here.
Sure.
So,
I just wanted to clarify.
I think that helps.
Okay.
That helps.
Thank you.
Thank you. I think the next one is SRv6 mobile user plane. I think I haven't seen many discussions. I think I understand there's a lot of good work is going in, but I haven't seen many discussions. But I understand 6-man is going through extensive reviews of that. I think from our point of view, I think for us to really complete the work, we need to understand the implications of 6-man discussions on this one, right? I think there may be a bunch of issues in 6-man. If they're unrelated to this base spec, we are okay with that. But if any of that issue is impacting this specification, then we need to be aware of that, and we want to make sure those issues are addressed. I hope that's reasonable step. And I think we need to plan for readiness. I think last call readiness, right? I think we need more participation, more reviews. I think I understand authors are doing some phenomenal job, but we need. I believe Suresh is trying to say something. Hey, Karas, do you know how to activate the audio here? This is the right button.
Hey, Sri.
Hey, Suresh. Yeah. Please go ahead.
Yeah. So there was a discussion of this yesterday in 6-man. There's going to be a session on Friday in 6-man as well to close any of the SRv6 open issues. So I think it's like highly related to that. But I don't think there's any showstoppers personally, but we'll see how things go for this. Okay. So I think the TLV is potentially the like one thing that may take a little bit to resolve, but don't worry about it. Just plan independently for this. Okay. I'll take care of it at a further step.
Okay. Excellent. Glad to hear that. I think, yeah. So as long as any of those issues are not impacting this, work here, I think we are good with that. Yeah. The TLA discussion, I'm hoping should not impact this. Yeah. Thanks, Suresh. Yeah. Thanks for that clarification. Next one is we have the FPC document. I think this is somewhat in a weird state. Actually, this is incredible amount of work went in, but suddenly it's like a light switch overnight. This totally no response. Right, not much happened. Right, I think. But today, Charlie is the action item to give a status on what currently the document has expired. I think that's what. We can forward the document because it has addressed, from what I understand. I think last time, it has addressed all the comments. It's just, external reviews are pending, right? But from the author's point of view, they believe it's done, but the document has expired. I think that we need to see a live document. I think, but we'll have a separate discussion on that. And the 5G user plane analysis, Shinsuke-san, so, last time it got adopted as a working document. I think there's a 0.1 version posted in March, right? I think, yeah, we need more reviews. It's in early stages. This document is in early stages, but it needs to move forward. I think, yeah, that's about it. I think with that, right, I think we'll get started with our first presentation. And that is, if I can figure out. Yeah, the first one is control N6 control data plane N6 steering, Umberto and Marco Levish. Marco, Umberto. On the, yeah.
So N6 traffic steering.
this the way to proceed?
You want me to adjust this? Oh, one second. Okay.
Yeah, please.
No, yeah.
Thanks. So with this contribution, we actually want to complement the work which has been done so far quite some time on the mobile data plane, but actually focusing on an interface which is not well represented in 3GPP, who was in charge of specifying the 5G architecture. So far, you see the reference points between a mobile device and its correspondent service. In between, you have the data plane, which is under control of 5G control plane. But we address actually the N6 interface, which is between the user plane function, serving as a mobility anchor, and the actual application service in the data network. So if we want to be in charge of full end-to-end data plane control, this interface has to be represented somehow. So this is just a repetition of the slides for about 2 exemplary use cases which we presented already last time. So just to show that in 5G, it's possible to have multiple PDU session anchors, mobility anchors. Here, and if you have multiple sources of correspondent service, you have to somehow control that the downlink traffic reach the most suitable anchor. So how to do that traffic steering and treatment of data plane on this N6 interface, that's actually what we want to address. Another use case is more from the automotive space. Then if you talk about low latency communication, so many people think about moving some application services to the edge. And now if you have moving vehicles, to maintain that low latency communication, you may need to relocate from one edge cloud to the other one. At the same time, using the same IP address, the vehicle may be connected to a service in the central cloud. So how to enforce traffic treatment policies on this N6 interface, same applies here with one and single solution. So the scope of the draft, that's tricky.
I can adjust.
Yeah, thanks for tuning.
Yeah.
So the scope of the draft actually proposes leveraging a 3GPP component, which is the application function. It's a pretty general function, communicating to the 5G control plane using the 3GPP principles, which is service-based architecture and REST kind of communication. But the semantics, it's a pretty high level in terms of specification. So that's what we want to address mainly. And then second, to be flexible in how the application function is deployed in terms of transport network controllers that can enforce on a southbound interface. That can be FPC, that can be any kind of programmable protocol interface or open flow or whatever, to push policies to regular data plane nodes, which need to be programmable, but they are actually out of scope of a 3GPP architecture. So the draft wants to address the use cases and exemplary operation. Second, that's the main focus. We want to focus on the semantics and the data models on the 2 interfaces, which is between the application functions and the 5G control plane. And second, between the application function, wherever it's deployed, and the southbound communication to the distributed data plane nodes. So the status of this draft is that we actually try to connect to some people before the last IETF, actually. And we received some interest and valuable comments that we could take into account in our very first draft, which we published in September last year. The draft has been discussed at IETF 103, where we had more comments and feedback than we expected. So we saw that there is quite some interest in this work. And also after IETF, we received more comments, in particular for the application with the ETSI-MEC architecture, its integration with 5G system, and in particular also for the automotive use case. So there is some visibility of such work. And if we look at other SDOs, ETSI-MEC as well as 3GPP are currently looking at how edge clouds can be integrated well with 5G control plane. So the current draft
which is the first revision, has the following aspects covered. So deployment and operational aspects. We have first sequence charts, architectural aspects being described. We introduced the concept of loose coupling and tight coupling on the N6 interface, which is basically the way traffic treatment policies are enforced on the N6 endpoints. So we have two options here. It's basically a deployment choice, and both have pros and cons. We show that later in the slide, and we have first semantics and operational aspects being described in message sequences. More energy needs to be brought into that to find a good model how to describe the semantics, which is very different in the wire protocols being used between AF and the control plane, as well as between AF and the actual data plane nodes. So here we want to be flexible in the protocols being used. On the one hand, being applicable to 5G per 3GPP specification, and on the other hand, being flexible in the protocol choice made between the application function and the data plane nodes. So the two coupling approaches, I don't make it three, please.
Sorry.
Thanks again. So on the application service side, on the data network, everything is the same. So the difference between loose coupling and tight coupling is mainly on the side of the mobility anchor, which is under control of the 5G control plane. So the upper picture we call loose coupling because the UPF side of the policy enforcement for traffic treatment is basically as much as possible independent of the 5G control plane. So you have a transport network controller where we place the application function as a binding element between the N6 traffic treatment control and the 5G control plane. The lower picture, which we call tight coupling, so the UPF side of N6 policy enforcement is at the UPF, the 3GPP data plane node. So here, the same could be achieved, but you depend on the 5G control plane to push and enforce policies on the 3GPP node, which is the UPF. The upper picture, you can actually handle as most as possible independent of bothering the 5G control plane. The lower picture may also have some advantages, depends on the deployment in the actual case you want to enforce. There are immediate questions for that, or?
Your fonts are really small, so I just want to get close.
Okay. So last but not least, so we don't want to explain the operational and semantics aspects. If you're interested in that and want to contribute, we appreciate. So all of that is currently written in the first revision of the draft. So just for here, we want to show one example how that could be deployed. For example, as so addressing one of the current studies in 3GPP and also in ETC-MAC, how the MAC architecture can be integrated well with the 5G system. So what we propose here, so the green parts are actually edge cloud components. So you have a MAC platform, you have multiple MAC hosts, MAC A and MAC B, and per the ETC-MAC architecture, there is a MAC platform manager, which is under control inter alia of the traffic treatment policies on the MAC host. So we thought it's wise to place the application function on the MAC platform manager, which is then under control of enforcing policies that apply to traffic between a V2X application, as an example, and the actual vehicle. So as one example, we could indirect traffic for whatever reason, failure handling or load distribution between a UPF that's being assigned and under control of the 5G control plane and a new V2X application on a different MAC host. So this can be done without having any signaling going through the mobile corridor. So you can handle that on the edge cloud side. Also, if we want to have, for example, due to mobility of the vehicle, some relocation of the edge cloud, the same could apply, whether you use a single MAC platform manager or multiple ones, each responsible for each MAC site. The same could apply. So the mobile core at least have to take care of setting up a new UPF serving as mobility anchor in the new Mac site. And then all this relocation of traffic you could handle on the green part, enforcing policies on the N6 interface. So during the handover, you may forward traffic between EPNs, so the UPFs may not be involved at all. And you can apply for traffic forwarding and steering any kind of protocols like locator rewrite, segment routes, or whatever is being suitable here. Carlos?
Yeah, Carlos Bernardo, Stream. Just to comment that on this stuff on the MEC for the vehicular, we may, the Fire Transformer project, which is a European project that I guess you are familiar with, we are doing things with MEC and vehicular stuff, and I guess we may be interested in evaluating this from a practical viewpoint. So maybe we can discuss offline.
This sounds very good. Yeah, there are multiple automotive-related projects where this may be of interest, and yeah, let's talk about it. Charlie.
I'm Charlie Perkins. I'm sorry, I'm not automatically understanding all the acronyms you have up there. So MAC, Mobile Edge Controller or something?
Yeah, or nowadays multi-access edge cloud.
Okay.
Edge computing.
And well, V2X, I reckon, is for vehicles, and TN,
Transport Network Controller.
Transport Network Controller. PF is packet forwarding somehow, or
no, that's a Mac host that hosts an application, and the Mac Platform Manager. That's a component of Etsy Mac architecture.
And AF is application function,
exactly.
Perhaps? Well, that helps a lot. Did you say that already and I just missed it?
No, maybe I
Okay.
missed to mention some of the abbreviations
So
here.
what is the approximate range of one of the multi-edge controller things? I mean, is it a mile or a suburb or?
You mean the scope
Yeah.
where the Mac Platform
Well,
Manager has...
how far do you have to drive before you go from one Mac to the other?
Well, this is just an example. So I think Etsy Mac specifies the Platform Manager's scope in grouping a logical set of Mac hosts, which are under control of this Mac Platform Controller. So in particular, if we talk about moving from one administrative domain to the other one, for sure there will be two Mac Platform Managers which have to talk to each other. If the two different edge cloud sites belong to the same administrative domain, that may be dependent on one single platform controller. So we just show having two platform controllers, but that's not binding to the use case.
So even if the regions are not contiguous, but if they're under the same administrative domain?
Within the same administrative domain, that may be under control of a single platform controller, which is even easier than in that case.
So I don't have an idea of the scale here. I mean, is it like 1,000 cars under one Mac? Or
I cannot say. We just take the architecture, the responsibilities of the platform manager regarding the Mac hosts, and that's where we try to apply the architecture. So maybe I'm the wrong person to talk about all the details of Mac architecture, but
well, I hope you don't mind me asking, but in terms of understanding scalability, it's kind of nice to know these things.
Yeah.
Thanks.
Yeah, I'm very curious about answering these questions as well, but I think Etsy Mac architecture is not as far. So many of the interface semantics and scope aspects are not well defined as far as I heard. Tom?
So it's Tom Herbert. So it's not so much about the architecture scalability, but if this is about low latency, then all of these paths are relevant, right? So from the end device to the mobile edge host, what does the path look like? So obviously the fewer hops we have, the better. How many handovers do we have every time we cross a different cell site, for instance? Are we connecting to a new MEC? So the architecture from that point of view may make sense, but obviously what is the use of this to get the manifestation of low latency and those properties?
So I think also that's an interesting question where we may not have one single answer. So it depends a lot on how edge clouds are being deployed. And that differs from operator to operator. So some operators may see many decentralized edge clouds where they want to deploy Mac. Some others say a few on a certain geographical region are fine. So that all has impact on how often you really need to relocate between one edge to the other one. In terms of low latency, of course, it depends on the performance between the edge and the vehicle. So it depends on capacity and all that kind of requirements.
Well, the good news is that if you believe in the goal of 1 millisecond latency in 5G, all of this means it has to be super simple. So this collapses into very simple paths, like from my device to the host, I have like 1 or 2 or 3 hops. It has to really, really compress. So I think that's actually a good design attribute. If you consider that low latency, that will enforce the conclusion that your network has to be very simple and very flat in order to get this. So it's kind of hard to tell from this path, but I think you're heading in that direction.
Yeah, so if I mention low latency communication, I'm not necessarily implying the 1 millisecond kind of reference. So today, anyway, most of the latency comes from radio. So that may change in the future. And there are more reasons than low latency to put a particular service to the edge, which is reliability and offload from the core network. So,
Anne Flink from Nokia. Just to answer Charles and the previous question of the scope of the NEC server, its latency is the most defined parameter, the end-to-end latency. So what we are looking at in 5G environment, it is something below 100 milliseconds to 10 milliseconds. And of course, that's a question of deployment and money, then how many servers and where do you locate this? It can be part of the RAN system, or it can be next to your base station. It depends how deep pockets you have.
I'm Shuping from Huawei. Thank you very much for your work. I think it's very important to consider also the M6, and that is in that case we could achieve the end-to-end solution. And you also mentioned the SRv6 to support M6. So could you elaborate a bit more on this? Your thinking on using SRv6 to support M6?
So our intention is to keep the draft more or less independent of, or let's say, broadly applicable and not dependent on a particular protocol that you use for traffic steering. That's why we said it just depends on the policies that are enforced between AF or the controller and the data plane nodes. So the endpoints that enforce traffic treatment policies, that can be something like segment routing. It can be a tunnel, that can be ILA or some kind of other locator rewrite. So I don't think this work should be specific to one particular protocol, but be flexible in the deployment choice, which protocol is being used, and segment routing is definitely one of the candidates.
Yeah, sure. It could be one of the candidate protocols.
Yes.
Thank you.
You're welcome.
Yeah.
All right. You have 30 seconds to wrap up?
Sure. Yeah. But maybe I have one follow-up question. But with respect to standardization, is it, I think 3GPP, 2 points. 3GPP doesn't recognize any node on N6 today, right? Does this spec now requires that the AMF, SMF functions or the core functions require a new interface and it should recognize a new node in addition to UPF?
So I think new interfaces should be entirely out of scope of 3GPP. The only, could say, synergy that we see is in the semantics that apply to the communication between the application function and the rest of the core network, which is basically the PCF, SMF. So here, so let's start bottom up. So we see quite some liaison and synergies with what 3GPP currently discusses, and they recently started a study item on edge cloud integration with 5G system. So we may have some valuable input here. Also in ETSI-MAC standardization, they look at how ETSI-MAC interworks and can be well integrated with the 5G system. So we see some synergies here. How much impact we have in leaving some specification out and giving it to other SDOs like 3GPP and ETSI, that's something we need to find out.
Okay.
Yeah, David Lake, apologies for a late question. You mentioned the liaison work with 3GPP, which I think is very important. You also talk about moving the device to the edge. Would that impact N3 in any way? Because N3 is already set in release 15 and 16 and is GTP. So we're back into some of the discussions we've had in XCMech about bumping the wire for GTP. Or would you always try and negate that?
So whatever is to be done on N3, it's under control of 3GPP and the 5G control plane. So I don't think we have interference here, because the policies that we consider for N6 traffic steering is in between the UPF, which serves as either uplink classifier or PS session anchor, and the data network. So N3 is between the radio base station and an uplink classifier UPF. So I think this is more complementary than interfering.
Okay, last question here.
Yeah, Cisco Systems. Very good document. Do you have any correlation with the network slicing?
Of course, it needs to complement each other. And also here, I don't think if we deploy a particular automotive slice for that kind of service, there is interference, though we don't address particularly the slicing aspect in the draft. So slicing mainly comes, okay, in slicing you may have an orchestrator that's in charge of lifecycle management for a particular slice, but also you have to have components that enforce traffic treatment policies on the slice data plane. So I think all of that, what the draft talks about, can be complementary to a slicing approach.
Okay.
If
Or
you
maybe
see,
we can converge.
sorry?
Maybe we can converge.
It can be converged, yeah. So if you see any particular interference, please raise your hand and let us know.
Thank you.
Okay, so author's intention anyway is to revise the document structure, because in the 0.0 version we have a long introduction telling about the background and deployment applicability. So I think we need to focus more on the actual scope of the draft. After there's common understanding, then we need to converge on a suitable notation for both the operational aspects, also here to have a description which fits into 3GPP service-based architecture between AF and 5G control plane, and then also for the semantics and model description that apply to both of these interfaces. So tentatively, we target a clean update by June this year, so we have sufficient time before IETF to elaborate on a further update if needed. And yeah, two last bullets with question marks behind. We addressed the last one, which is there any liaison to be done and enforced now with other SDOs? And the one before is there some interest in this working group to jointly push and progress this work?
Okay, quick question, yeah.
Yeah, I just have this is Charlie Perkins from FutureWay. So just a comment on this slide. I think clearly there'd be a lot of interest in the working group for something in this area, but maybe before adopting the draft, it'd be good to see the clean update.
Yeah.
So it looks to me like it's a substantial revision.
Yes, it's a substantial revision. Nevertheless, this is new work, and I think posting a 0.0 draft, it makes sense to spend a little bit more text on the background, but now we are ready to clean it up if there is common understanding. And
so one question is, with respect to standardization, there's no protocol elements here, right, Marco? This is more about a model, right?
It's
on standard strike. It's being proposed on standard strike. I'm trying to understand what exactly from standardization point of view. Yeah.
Yes, so it's information model which can be directly mapped to the protocols that apply between the two interfaces, northbound, southbound to the AF, and some exemplary deployments.
Okay, excellent. I think great stuff. Please provide some feedback. I think this is a good document. Definitely, we want to adopt it if there's sufficient interest and if there are no hurdles, process hurdles. But yes, thank you so much. Next one is Charlie Perkins on FPC status update. Yes.
Can you hear me? Yep. Okay. So this is the only slide. We have this draft on control plane, forwarding plane separation. It's been, it's a lot of work has gone into this draft, and it's actually in relatively good state, but it hasn't been commented on or revised since the summer. So it was requested that we try to find a way forward with this, and I'm not exactly sure how to get more comments on the draft. So that's the main point, is to make sure that the working group is satisfied with it, review the draft, and so we can go through last call and for request publication. So the draft has basically got a lot of functional module definition and information model in the main part of the draft, and then there's a relatively large appendix for Yang data model that goes along with the information model, and that's a lot of text, and it actually involves using some existing Yang model and defining some new things, and this is not really something that I know a lot about. So it seems to me that possibly the draft would progress faster and get more comments if we were to split it into two drafts, but that's not required. And I mentioned here two points of view. One is that if it stays in the same draft, then any changes to the information model are more likely to be immediately reflected into the Yang data model, and or even more to the functional interfaces between the functional modules. Or if you split it into two drafts, then we can focus on getting, I guess, the more important content out, and then get the Yang shortly afterwards. But we need to get reviews, and we need to find a way to get it done. And it may already be done, but we have to get reviews to make sure of that. So I could update the draft just to maintain it. In other words, resubmit the text as it is. But anyway, the point of my single slide here is to request a discussion in this room about what the best way forward would be for this draft.
Yeah, I think Suresh has a comment. Suresh?
Hey, Charlie. Yeah, I think you have a good point, Charlie. I think two drafts might be easier to get review with, but the issue I have is the person who's going to review the Yang draft needs to understand the other draft as well, right? So it's like a slight win, but not that much of a win. So one of the things I talked to Sri and Tapeng about is to get some review from somebody with good 3GPP knowledge. So the person I was thinking of was Lionel. And as if you know, like Lionel just got promoted to CT chair, so I'm not sure how much time he would have, but I'm going to still keep bugging him to make sure I get a review of him. So that would be somebody who has an interest in getting this working.
Yeah, that's a great idea. Yeah.
Any other comment?
So Charlie, when can we see an updated live document? So that it's currently it has expired, right?
Okay. So we have one meta comment, not any comments on the draft right now, no open tickets, and that's it. Okay, thank you very much.
But my question was, when can we see an updated document so that we can,
today, if I get the XML.
All right. Thank you so much. Okay, thank you, Charlie. Blue sheets, please. If anybody hasn't signed the blue sheets, please sign the blue sheets, please. And the next one is SRv6 for mobile user plane, and update from Satoru-san. Thank you, Charlie. That's nice. You can take this.
Hello everyone, Satoru Matsushima. I'm presenting ESRv6 mobile user plane update. It's this time very lightweight update due to some limitation of the time. So we had a good feedback from the reviewer. Thank you very much. So what we had update is pseudocode correction, which funded by Kentaro and others. And the other is some clarification text for predefined service function and traditional mode and IPv6 user traffic and the argument named as the mob session. So otherwise, simplify the text regarding network slicing. So other point is naming compliant. We had some comment in previous meeting that naming is not applicable for, appropriate for that. But in terms of the argument, we have no idea received after the last meeting. And other naming is t.m.tmap. Kentaro has suggested us to use t.m.gtp4.m.d, sorry, as a kind of the follow the function name instead. Other major feedback from reviewer was whether to support drop-in scenario, which is demonstrated by Schmidt in last IETF hackathon. The drop-in scenario is like the packet received from GTP side and then translated to the SRv6. It then translated again to GTP4. It enables the user plane path to be able to handle by the SRv6 function in the middle of the mobility path. So that requires some mapping rule change. Currently, we have a source IP address of the GTPU into the seat as the destination IPv6 address, but it needs to be in the source side and with the UDP source port to reproduce the UDP source port to keep the transparency. So please, next slide again. So I have a hackathon project during that weekend. So we had the hackathon project to target to implement two functions for the SRv6 to GTP and GTP to SRv6. Code is now available on GitHub, both for the BPP and P4. So during this hackathon, we studied how to deal with the suggestion to support drop-in scenario and also to follow the argument format to be integrated into that translation scenario. So we have well studied what we're missing in the current specs. So, but now I haven't clear text in the draft, but the guidance to implement that function is my ugly handwritten illustration. I'm sorry for that, but my colleague worked very well to implement.
Good artwork.
Yep. So I think we are with this. I think we can update the draft based on this outcome and takeaway in the next meeting, next revision of the draft. So next slide, please. I couldn't mention the detail of the new mapping rule, but you can read and chase the arrow. So next step, we need to handle the review comment correctly and reflect our analysis based on for the review comment. I think almost all comment come from the unclear text. So then I think we can deal with that comment with the improving clarity and readability to deal with that comment. And of course, other feedback from working group group is really welcome. And the second thing is update mapping rule between GTP and SR-basics, as I mentioned in the previous slide. So last thing is implementation. Now it's available in open source. So please check it out to your laptop or anywhere else. That's all. Question?
So yeah, open source, I think it's a great thing, Satoru-san. If you can send it to the mailer, about the open source links and other things, that would be great.
Yeah, we have, even for that hackathon, it's really limited time, so we only had 2 functions. But if anyone else interested in to develop other function, please join us.
Right.
Robin from Huawei. I have much interest in the hackathon activity. I want to know that for this one is based on the VPP, right? Okay. There will in the future there will be some of the project in the VPP for this one.
If accepted, yes, but I'm not sure with the VPP community access or not. But I think we can introduce our effort to the VPP community.
Okay.
Okay. Any other questions, comments, feedback? Eric? Yeah.
Eric Klein, Hisashiburi desu. You showed a diagram of mapping IPv4 GTP addresses into SRv6. Is there a mapping for v6?
V6?
Yeah.
V6 for what?
GTP encapsulation?
GTP over IPv6?
Yes.
Okay. Yeah, actually we have another function to enable us to translate between GTP over IPv6 to or from SRv6. The trick is to using the 2 seed. One is the pointing the gate border locator and TID. In addition to that, we have another sheet to indicate remote endpoint of the GTP. That's a trick. Okay. Please, I think you can find the function, how it works in draft.
Okay.
Its name is n.m.gtp6.e.
GTP6, thank you.
Okay. Thank you so much.
Thank you.
Yeah. All right. Next one is scalable deaggregation for DMM by Fred Temple. Fred? Yeah. Strange. Wow. So it can be reached. You have your own laptop, Fred? Okay. I think we're okay. Fred, you're okay. Yeah. Yeah. Yeah, this is a new proposal. Yeah, we can, yeah.
Okay, talking actually about 2 drafts, but I want to focus on what we're calling scalable deaggregation for distributed mobility management. For civil aviation, we have a situation where we're going to have each aircraft as a mobile network that receives a mobile network prefix. That mobile network prefix might be for an airplane /56. That's the current proposal, is that airplanes would get a /56. And they carry that /56 with them wherever they go. Numbers of aircraft operating worldwide today is currently in the order of tens of thousands, perhaps growing to hundreds of thousands in coming years. However, we're starting to see unmanned air systems and personal air vehicles as anticipated growth in the near future. So we'll soon need to consider larger orders of magnitudes in terms of the numbers of mobiles. Also, mobility plays a role in control messaging overhead, and aircraft are highly mobile. So we need a system that scales not only to numbers of aircraft, but to the amount of mobility signaling. So I want to talk about centralized versus distributed mobility management. In centralized mobility management, we would have one mobility anchor point for the entire worldwide aviation environment. So you can see where I'm going with this. You've got thousands upon thousands of planes all grouped around the same mobility anchor point. Advantages of CMM are that you get immediate mobility and quality service signaling, since all the aircraft are serviced by the same mobility anchor point. Disadvantages are that your scaling limitations, not only in terms of the number of aircraft, but also in the amount of mobility signaling. And also, localized mobility events cause global instability. So we really need to move away from the CMM model, and that's where we start to talk about distributed mobility management. In distributed mobility management, we might have many regional mobility anchor points, perhaps maybe hundreds or thousands of them, to distribute the scaling load without impacting the global routing system. So here you see the arrangement that we advocate in the draft, where we have a global routing overlay system that runs BGP as a core autonomous system with the mobility anchor points in spokes. So it's a hub and spokes arrangement, and the mobility anchor points are stub autonomous system border routers in BGP. Now, the advantages of this is that it distributes the load amongst many maps, scalable in terms of numbers of aircraft. A single BGP routing core, we believe, can service up to 1 million /56 prefixes. It's also scalable in terms of mobility signaling because the localized mobility events are kept local without causing global instability. The disadvantage is that in order to keep the load out of the BGP routing core, we need an effective route optimization service to reduce congestion in the core. But the good news is that we know how to do this. We have mechanisms for route optimization. And now, can you go back one, Sri? Oh, am I missing a chart there?
Maybe you can you flip it back?
Oh.
Yeah. Okay, I will just, yeah. This is the one, right? Okay.
Sorry. Can you slide it down?
Yeah, sorry, this is a little bit thing. Oops. Yeah.
Yeah, where it says massively distributed mobility management. Can you slide that down?
You may want to just, I think, yeah.
Oh, okay, you're skipping the chart though, Sri. How's this
Okay.
not working?
Let me go back, sorry. I think I was. Okay, the CMM considerations. This you're done, Fred?
That's done.
Okay, yeah. Now let me control. This good?
It's not.
Next slide. Okay.
The one right before this.
No, I'm not controlling it, Fred. Yeah. Okay.
Okay, so all right, so that may be the best we can do. But this is what I'm calling massively distributed mobility management. And you can see in the bottom part of the chart here, we've got many of these BGP routing cores.
Oh, sorry, maybe I should not. Okay, go ahead. Sorry.
All right, so the picture's not going to be shown, but you get the idea. Thousands of these BGP routing cores as independent hub and spokes networks. Jays. Okay, so The entire system is going to support a very coarse-grained mobility service prefix like a /32. Each one of these thousands of routing cores is going to maintain an independent BGP routing information base with up to 1 million mobile network prefixes per routing information base. So each routing information base is going to service a different mobility group prefix, like a /44. So the mobility anchor points are going to appear with each routing core and apply route filters so that mobile network prefix registers with a single routing information base. So if we had 1,000 routing information bases, each servicing a different mobility group prefix, the total system should be able to support up to 1 billion BGP routes, 1 billion aircraft with their individual mobile network prefixes. Mobiles can register with any available mobility anchor point. Route optimization keeps the data traffic out of the core, and mobility anchor points keep mobility signaling out of the core. So these are the two drafts. A simple BGP-based mobile routing system for the aeronautical telecommunications network is a working group item with the routing working group. It also addresses the distributed mobility management solution that this group is discussing. And then we have the scalable deaggregation for overlays using the Border Gateway Protocol. And this is a new draft, and it talks about this massively distributed mobility management that I referred to earlier. One other thing I'll say is that we have a group in Austria from a company called Frequentis that is experimenting with and evaluating this proposal. And they noticed that with BGP, when you withdraw a route from the routing system, it can take several hundred milliseconds for that route to go away. And during that time, you could have packet loss if the previous nodes didn't remember the link layer address of the next hop from that route. And the way we get around this is that we actually have some hysteresis in the system that allows nodes to remember where that mobile node was before the route was withdrawn. And they remember for 40 seconds, so that gives ample time for BGP routing to reconverge. So it's a combination of the BGP routing at the network layer and also forwarding at the link layer that keeps from losing packets when we have that BGP route withdrawn. That's all I have for now.
Okay. Tom?
Tom Herbert. So massive is relative, right?
Right.
So on one hand, massive may mean 1 million or 10 million aircraft. But if we're talking about all worldwide mobile devices, it's several orders of magnitude greater. So I wonder if you can comment on, first of all, does this scale to really big numbers, like the billions and billions of mobile devices? And secondly, the other part of this is, what is the, how dynamic is this? So if I have a lot of mobility and things are constantly changing, that's obviously going to generate load on BGP, which I don't think it's specifically designed for.
That's two excellent questions. So this system we've more or less sized for 1 billion mobiles. To go larger than that, you start pressing on BGP peering limitations. BGP routers can handle about 1,000 peerings. They can't handle hundreds of thousands of peerings. So that's where you have a little bit of limitations in scaling, because the numbers of BGP peerings. But if you wanted to have billions upon billions, you could have multiple instances of this, each of which instance services 1 billion prefixes. In terms of the mobility, these mobility anchor points concentrate mobility in a regional area. So if I'm in northwestern United States, I would pick a mobility anchor point that's located in Seattle. And only if I move to, say, New York, would I move away from that anchor point. So you have localized mobility is contained within the regions, and only regional changes get updated into the BGP. So that's how we keep the mobility churn out of the BGP routing system.
Yeah, Fred, thanks, Srigandavelli. So the prefixes that are allocated to the aeroplane are locally anchored at the point where they begin, or how are they? Is there a hierarchical mobility here?
It's all deaggregated, Sri. So the /56s that the airplanes get, when I move into, say, New York, I sign up with a mobility anchor point, and I say, here's the prefix I would like to assert into the network. Please use this prefix in traffic that comes back and forth to the airplane. If I move to Los Angeles,
Mhm.
I withdraw the prefix from New York and
Good.
assert the prefix in Los Angeles.
Okay. So there'll be a BGP update each time aeroplane moves out of the one location area.
only
to
when it
another.
moves for a
Oh,
far distance, though.
Sure.
Yeah.
Thanks.
Charlie Perkins, Future Way. So I have two questions. First one, I'm sure you looked at HMIP, hierarchical mobile IP, and the figures from HMIP look a lot like what you already drew, and even they use some of the same terminology, map and so on.
Yeah.
So there should be some overlap in the solution space there. I guess the main point of difference is that they never really considered using BGP when they were doing HMIP, but that brings a lot of, as you pointed out, additional protocol that needs to be tuned for this purpose. So I was wondering, also there was FMIP, Fast Mobile IP, which really does a great job of solving the handover problem, because you can have that since really the temporary tunnels that go from previous to new access point and so on. So is that applicable here as well?
If you look at the mobility anchor points from the, let's see if I can go back to this. Geez, this thing is not working still.
That's
an
weird.
amazing bug.
It's not,
So anyway,
Sorry,
so
Fred, yeah.
the diagram where I had the hub and spokes, Charlie,
Yeah.
where those mobility anchor points are out in the spokes, each
Right.
one of those mobility anchor points could be a HMIP.
Right.
It could be an HMIP domain, yes. So yeah, that could be an HMIP mobility anchor point. What ICAO is looking at today is 3 alternatives for the mobility solution. One being PMIP, the other being LISP, and the third being Arrow. So each one of these mobility anchor points could be a PMIP or HMIP domain. Now, in terms of the fast mobile IP, maintaining routes while you've got some instability so you don't have packet loss, that's one way of doing it. We have another way of doing it by treating the network as if it's layered with a network layer at the BGP level and link layer information at the tunneling level. So when you have a BGP route withdrawn, as long as you remember that old tunneling state, you can continue to forward packets during that period of instability. So it's achieving the same sort of thing as fast mobile IP, yes, but I think it's slightly different in the way that's doing that.
Yeah, it sounds different because you have the layer 2 tunneling and so on, right? So,
well, when I say layer 2, I'm still talking about IP, but the layer below IP.
okay,
So,
right. Well, there's no limit on the number of IP layers you can have anyway, so.
that's true. They can be turtles all the way down.
Right. So now the second question I had, so I pretty much believe that this has a lot to do with not letting the airlines crash and everything. And, but there's another factor coming into play in the airspace, I understand, to be the drones. And that would boost your scalability requirement quite a bit.
Yeah.
And on the other hand, it seems like that the overall design should be able to handle knowing about the effects of these additional airborne objects.
Yeah.
Is that under consideration at all?
Absolutely. And in fact, Charlie, I was on a NASA program 2017 to 2018 called Communications, Navigation, and Surveillance for Unmanned Air Systems. And we were specifically asked to look at what happens if you have a worldwide explosion of drones that all need to be in communications. And that's where we got some of this sizing and scaling, guidelines from, is this consideration of what's going to happen when the drones and the unmanned, freighters and things like that start flying around.
Right. So, I mean, you could have it so that if any drone that's registered is doing the right thing, and if you detect one that's not in this system, or in other words, doesn't have a route from the global overlay routing system, it's considered to be an intruder or something like that, and something bad happens.
Definitely network authentication and access control, allowing only trusted nodes to join the network is very important. And bad actors, there's several ways of finding those and identifying them.
Okay, thank you.
Okay, thank you.
Okay, thank you, Fred. Next is Shunsuke Home on Oh, I know. Sorry. I think we need to reload the pages. No, I did upload. This one, right? Oh, user plane, not features. Yeah. Sorry. Okay, this document was adopted as a working group document in the previous IETF.
Yep.
So, yeah, Shunsuke Home, please.
Hello everyone. I'm Shunsuke Homa from NTT. So I will report update of user plane protocol and architectural analysis on 3GPP 5G system. So I already presented this draft several times in past meetings. So I'll skip the background. Sorry. Oh.
Let me know what slide you want to go.
Okay, so
slide
this slide shows the history of this draft. So as you know, this draft was adopted as working group document in January this year. Thank you very much for your support. And after the adaptation, we received some feedback from 3GPP, and we updated the feedback on the draft, and published the new draft at 11th March this year. So I will explain the content of this update in this presentation. So following two slides shows the list of major updates. In this updates, for example, we started clarifying specification of PFCP as control plane protocol related to user plane manipulation, and added terminology and definition of PFCP, PDR, and FAR in this update. Also, we clarified the differences of definitions of IPv6 multi-homing between 3GPP and IETF. So in 3GPP, a branch of single prefix is not called multi-homing, so it's different from IETF definition. Also, we received request to add end marker support, and we reflected it on this update. And as the update point, having a large impact is specification of network slicing. So as you may know, specification of network slicing was added in the current 3GPP document TS23501. So in this specification, 3GPP has assumption to use network instance to glue UPF and transport slice. And we derived 3 ways to glue UPF and network slices with a network instance from the specification. So I will explain the details of the specifications and our analysis in the following few slides. So this slide shows the overview of PFCP and network instance. PFCP is a control plane to handle user plane traffic, and it's used between MME and P or S gateway, or between SMF and UPF. So PFCP contains some information element, and information element is used to detect traffic and decide its forwarding action rules in user plane function. So network instance is one of information element, and it is used for detecting IP domain when network addresses or IP addresses of UEs are duplicated, like this figure. So this screenshot shows the added new specification related to use of network instance. So description of in the red box means network instance can be used to detect network slice based on SNSS AI. So from these specifications, we derived to 3 ways to glue UPF and transport slices. In this example, we have the assumption to use MPLS as transport slices. Option 1 means that UPF and P router are integrated as all-in-one box. And a UPF encapsulate appropriate MPLS detecting based on the network instance indicated from SMF. And option 2 means that UPF and customer edge router are integrated. Also, option 3 means that UPF is separated, completely separated from MPLS architecture, and put UPF behind of customer edge router. So this slide shows the features and challenges derived from our analysis. So option 1 leads UPF and P router is implemented as all-in box, and it may inhibit much better environment. Also, option 2 and 3, we assume that the specification, some specification, more concrete specification will be needed to write traffic on the appropriate slice, because P router can't recognize GTP header. So it's difficult to put traffic on appropriate slice. So, but 3GPP focuses on just only mobility management, and transport is out of scope. So maybe other SDO can, such as IETF, can standardize the specification how to glue UPF and transport.
So if I may ask a question, Shunsuke-san. So you will mostly analyze these different options in the IETF document and make recommendations, or what would you do it here in IETF?
If possible, I would like to proceed more this analysis. But
Satoru Matsushima, SoftBank. Yeah, I think this analysis is out to bring the much more detailed, correct information to IETF community.
Right.
So not only for slicing, but also as a mobility management concept appear on the 5G from 5G. So network instance, for example. So I think many people not aware of what's a network instance. Sure. Even for that, that 3GPP specification has not so much clear to define what a network instance is and how to relate it to the network slicing.
Right.
So that's information as the result of the analysis could be valuable for the IETF community as well.
No, I agree with that. I think this falls in the lines of what Marco was presenting on the N9, N6, right? Essentially, right? These are something new. Maybe IETF can take up and do some good analysis with the goal that 3GPP can consume. Please go ahead.
Okay. So, sorry. Lastly, I will mention the status and next steps of this draft. So we reflected all of feedback on mailing list and improved the content. And also, we will add clarification of PFCP related to user plane handling, because it will help for clarifying evaluation aspects on user plane protocol. For example, data structure of PFCP is very useful for clarifying user plane specification. So also further review and feedback would be appreciated. And if you have any request to clarify anything in 3GPP specification, we will welcome them.
Okay.
That's all. Thank you very much.
Thank you, Shunsuke-san. Any questions, comments, feedback?
Satoru Matsushima, SoftBank. Adding another document, another area of the 3PP specification, kind of the endless work. So I don't want to increase that workload. But it's good to study the user plane related specification to bring to the IETF community. I think I really appreciate to join other people and receive the comment. So in addition to that, regarding the PSCP stuff is slightly different concepts from the IETF architecture specification. So I think that clarifying the what the UPF exactly look like is very different. So I think the clarify the how UPF is defined is valuable to bring to clarify on this document. So still, IETF 3GPP document is updated continuously. So chasing that update is, I think, much valuable.
Right. So
yeah, thank
before
you.
John,
Thanks for this draft. Like I found it very
Yeah,
useful.
Suresh, go
So
ahead.
and I do follow like a lot of the 3GPP work. I just want to know, like, what is the end goal of this, right? Like, is there like so when this work is done, what do you want? Is RFC is an RFC what you want, or is there some liaison statement you want us to send towards 3GPP? What's the end goal of this?
And
So what is your success criteria?
What is the
much,
final
right? So,
objective?
Like, what will make you happy with this draft? Pretty much.
And so 3GPP specification is fixed, so we can conclude this one.
Let me
That will be you too happy if 3GPP are upset about it.
So release 16 was
I think it'd be kind of the continuous work. I couldn't see right now the end of the this work, but to chase to bring the analysis result to IT community is the purpose of this document. After the 5G specification is done and
no, but Satoru-san, like the thing I was asking is, right, because you're going to study some requirements and see what happens. So there's going to be some IETF protocol that meets it. Then somebody needs to follow up with work in 3GPP, right? So if you remember, like, like I was working on it, Sri was working on it in release 8 timeframe, right? We took the IETF protocols to 3GPP and started writing TSS, right? And is that like the way you want this to go forward, right? Like, because existence of an IETF RFC doesn't, it only helps like do something in 3GPP, but the work doesn't get done by IETF RFCs in 3GPP, right? So like there needs to be parallel work that happens in 3GPP too. So that's what I'm really looking at. Like, so what's your goal to do stuff in 3GPP? Does that make sense?
Yeah. Yes, makes sense. And I understand the 3GPP is not to tend to refer this document. I agree, but bringing the 3GPP information to IT community to find the gap is valuable.
Makes sense. Thank you. John? Yeah.
John from Huawei. I just wanted to add that this document is really useful. It does identify some gaps between what 3GPP defines in terms of transport segments and what is actually happening on multiple transports that cross across. So those views on transport and slicing, it could lead to, we need to do some work here, I think, to solve this. So I appreciate this document and would be happy to look.
Yeah, thank you.
Any questions, final comments? Okay, thank you, Shunsuke-san.
Thank you.
My blue sheets. Anybody, did everybody sign the blue sheets? I don't see them, they disappeared. If can please bring it up. Okay. The next one on the agenda is distributed mobility anchoring by Carlos.
So
That's a max, Carlos.
So it's going to be short anyway. So it's a short update on this draft. So go to the next slide, please.
Okay. No rush, we have time this time, yeah.
Okay, so version 12 was sent addressing the comments that we received during the working group last call. So very briefly, those comments were adding some reference and some text based on Fred's feedback. Then we did some minor editorials, and we also updated some references and do also some final proofreading and revision of all the draft altogether. So basically, we are done, and we are waiting for the software shares review for the next step. By the way, we received some minor things that we need to update from DAPEN. I guess that we wait until the final review and do all the updates in one single shot, right?
Right, yeah, both the chair reviews are pending. Maybe we can do update, then we can forward to AD.
Okay, so that's all from my side on this one.
Okay, any questions, comments? All right, okay. Sorry. And the last one on the agenda is PMV6 extensions for DMM, again by Carlos.
Okay, so again, very short. Go to the next one. So we submitted version 04, addressing also the comments that we received during the working group last call. So the main changes that we did, which are kind of minor, was one, we changed to experimental based on the discussion that we had with you guys on the intended status of the document. Then we did some minor editorials based on the feedback that we received. We were also checking the status of the different flags in the VU BA headers to basically adapt with the latest status. And again, we did also the final proofreading and revision. And we are in the same stage with the document like with the other one. We are waiting for the chair's review to update whatever is missing.
Okay. Yeah, I think, like I said, I think the chair review is pending. That's one thing. The impact of IPR declaration that will be analyzed, and we'll move forward on that.
Okay.
And any questions, comments? I guess that was our last presentation. If no other comments, we can close the meeting here. Mia has the notes, right? I think Mia saying you'll have the meeting notes. Okay. Thank you so much. Thanks everyone. Yeah. And the blue sheets, please. Right. The new ones I wanted to keep it new. That's the new ones I wanted to more discussion. These are like done topics, right? That's why I put. These are because these are done, right? These are, I was thinking more important ones at the beginning. No agenda, no plan, no strategy.